This is problem number 24, a classic Bayes theorem problem dealing with disease. We are given that 1% of the population is known to have a disease, and a test will detect that disease 95% of the time. So if 1% has the disease, 99% don't, but sometimes our test produces false positives. So of the 99% that do not have the disease, 0.5% of the time we're going to get a positive test result anyway. And we want to know the probability that a person actually has a disease given that the test indicates the presence of disease. So let us map out a sample space here. Here's our entire population. And this narrow slice over here, 1% of the population actually has the disease. 99% do not have the disease. And our test is going to detect the disease 95% of the time. And then of this 99% that does not have the disease, we're still going to get just this tiny little sliver, 0.5% of the population of this 99%. The test is going to show a positive anyway. It's called a false positive, .005. So, what we're being asked here, calculate the probability that a person has a disease given that the test indicates the presence. So that second statement is the conditional statement, given that the test indicates the presence of the disease. So we are living in this tiny portion of the sample space. And we want to know what percentage is this part of the total. So let's take 0.01% that have the disease times the 95% detection rate over the totality of all possible detections, both when they have the disease and when they do not have the disease. And if you run that through the calculator, you're going to get about 0.657. So the correct answer here is B.